Well, hey, hi there. How you doing? This is Robert again from the Amateur Machine Shop, and we're on another roll. We are cutting the splines in another axle to make some custom axles for a track car. We're running some high horsepower, and we're making them different length, and we're making them larger diameter, making bigger axles. This is only the second time I've cut splines on an axle. I bought all this equipment, and I can tell you I'm using an inexpensive mill. As you can see, this is, I would call it a Chinese no-brand mill. This is inexpensive tooling. Everything I'm using here is inexpensive to try to see if I can actually cut hard steel, which the axle here is pretty hard steel, 1050 steel. And I've got some tricks that I'm using to make an axle spline and to make the sprocket fit. And the word I would use is duplicate. I'm duplicating all the, all the axles are different. And so there's no book, there's no sizing chart for making axle splines, you'll find out. So I'm self-taught, I'm an amateur machinist, and I think we'll have another victory here. I'm almost done, so I want to show you, like I mentioned earlier in the video, how I'm setting up the depth, how you know how deep to cut your spline. There's no, I don't know how that's really done. I didn't see any videos that were helpful that showed how to do that. I'm going to show you how I've done this, especially if we have a victory and the sprocket fits this. I'm kind of 50-50 on whether this sprocket's going to fit this. We're cutting a 30 tooth. So let's finish cutting this first, and then right away, I'm almost done, we'll go to the table and I'll show you how I set this up. I'll talk to you, show what I'm doing here as we go along. Let me set this up where we can see what's going on here. We'll get a good look at this first. Okay, so we're going to cut some more splines here right now, and I'll tell you what speeds and feeds we're at. Let me start where I left off. So we're set up for 30 splines, rotating my dividing wheel correctly to the next position. I'm using a 2.5 inch 45 double 45 degree cutting carbide cutter. I'm running 175 RPM. It seems to be about right. It feels good, and the feed is very slow. Inch per minute, 1.65 inch per minute feed rate with this carbide cutting wheel. Seems to be working pretty good, and I see everything is flexing, everything is moving, everything is wiggling a little bit. I'm cutting 43 millimeters. I hope that's deep enough, 43 millimeters all at once. I'm not cutting it twice. I'm cutting each spline once. There's no reason to cut it twice. I'm going to manually remove reset to save time. I just enjoy manually bringing it back. And this is the second time I've done this. This is a big deal to buy equipment and do your own machine work. Send it through that way. Of course, you have to dig into your work. When you're cutting a wheel, you'll set up to where your wheel is digging toward your chuck. You certainly couldn't cut these spines with the reverse rotation. You find that out the hard way sometime. I hope not. The wheel is running clockwise into the work. So this axle was cut also. I cut 1.5 inches off this axle. That's one of the most difficult tasks, is to cut an automobile axle. It's hard steel and you need to use carbide bit inserts. Will not cut it. I don't care what you say. You need the diamond insert, referred to as CBN insert. And even they cut it difficult. You have to get used to it. They will cut an axle. I'm going to return this. See, it makes the cut once. It's not back cutting anything. Maybe right in the beginning it's not back cutting. It appears to be cutting the entire 43 millimeter the first try. You want to back it off enough to turn the axle. So you're aware of an index wheel and how this works. I'm set up to go 1 turn and 11/33 wheel. So you need to go 1 turn and back to your stop, 11/33. Reset the gauge. I'm using my auto feed. I'm also using an auto stop. I enjoy using this auto stop to stop the cut at an even point. Each spline is cut, stops at an automatic point. Makes for better work and a lot better work. Let's cut another one here. Okay, let's send it through. That carbide disc has cut a couple of axles already. I think this is the third or second axle. The third axle I cut. It appears to be like new. So far the carbide tips are not showing any signs of wear. I might be able to feed this a little faster, but if you keep feeding faster, if you keep cutting on your lathe faster, and hard steel is important to have slow feeds, everything. And this is carbide tooling, carbon tip tools, so you can't run those at a high RPM. That's normal speed. That's why it appears to be slowing. It's only 175 RPM. I can't turn that up like a CBN insert. I can turn that up to 500 or 600 RPM. Okay, we'll back cut this. And we're going to be exciting in a minute. We'll see if the sprocket fits this. Like I said, I'm an amateur machinist, I'm probably in way over my head and really enjoy my tools. This has some backlash in it and everything is wiggling a little bit. We are cutting hard steel. I wouldn't be surprised if everything is shaking a little and wiggling. But the first axle I cut, the sprocket fit, and it's on a car, and it's all finished. So I would say take it slow. Take it slow and enjoy a successful cut. Instead of trying to push it, you'll find out the hard way you pushed it too hard. You'll break some tools. Your work will come out unfinished. You'll have to make 2 passes. Something bad will happen, trust me. I've already got a small box full of some broken tools and cutting blades and so on. You probably guessed it. Being self-taught and trying to do my own machine work, especially trying to specialize in turning hard steel. But I've had a victory doing everything I wanted to do and learned how to do it a little bit. Let that auto stop. I'm going to show you how I set this up. There is no video exactly on how did I center this axle. You might be wondering, how do I center this axle? Well, when you try it, you'll realize you don't know how to do it. It's not easy to center. This tooling has to be centered, of course, on the axle. Soon find out you can't even center this tooling on the axle. I've got a system for that. I want to show you that. It has 2 things. I'm looking forward to sharing with people that may help another amateur that is brave enough to and wants to enjoy buying their own milling machine and doing their own work. It can be done. This is a 2 horsepower milling machine with a 40-inch deck. As you can see, it's large enough. I needed a large deck to set up the dividing wheel. To cut axles, you need a big deck. You need at least a 40-inch deck like this. This table is 40 inches wide, and so far so good. This machine is really strong and powerful for the money. It's inexpensive. A milling machine is very expensive and comes with a DRO. You can't do anything without a digital readout. Don't even waste your money on something without a digital readout. I couldn't do anything I'm doing without a digital readout. So this is set up. We'll cut my first cut here and see how we came around. We should be on 360. See, I didn't pull that back enough. Okay, well that's why you work slowly. Zero. We're back at 0. We're back at 360. This has got. Let's run through again and see where we're at. Okay, I really was not using any oil on this. It doesn't seem to help to cut splines with oil. I tried it, it just seemed to make a mess. I don't think it really helped cut anything with oil. But if you see here, I am, of course, using a DRO. You can't do anything without a digital readout. Trust me on that. On your lathe or your phone. We are set, the mill is locked down. The Z-axis is not moved a bit. This isn't even worth saying. It's locked down, so that didn't move. It's important not to move. We have the Y-axis locked down, 43 thousandths. And so the Y and the Z-axis is locked down. You want to do that, you want to lock your spindle. The spindle is locked tight. Everything needs to be locked down to achieve this, first of all. And like I said, we're only running at 175. And if you take a look at this carbide tool, it won't work. Don't let me show. This carbide tool, it's hard to see on here, but I am looking at it and it's a mess with oil, like I said. Let's clean that off, and I'm anxious to see this is a carbide tip. This is an inexpensive carbide. Is carbide. This is a carbide tipped 2-inch cutting wheel from India. I buy a lot of my tooling from India. Well, you can see maybe that I'm liking that. That is still gleaming and shining. The tips on this are still very sharp, so it appears that cutting 3 axles has not damaged this. So the moment we've been waiting for, we want to see if this fits and go on from there. But I want to remove the tailstock from my setup. I don't want to take this out of the machine. So we will remove the tailstock. Yeah, let's try this out and see. How I set this up is very interesting. I'm telling you, you're going to have trouble if you want to cut some splines for some reason. You're going to have trouble probably no matter what. It's not easy. I've been working in machinery and auto mechanicking and repair my whole life, so I understand enough to be dangerous, I guess. I understand enough to know what I'm doing, and that can go a long ways. I'm sure that went a long ways. So if you're very mechanically minded, it's going to help you get some milling machine, and my lathe is sitting right over there, and a lathe machine. Okay, so if we remove that, we can get to the end of this axle if we move the table over. So there's a lot of burrs on here. I think if it cut cleaner, there'd be less burrs on here. So here's the sprocket for this. And look at that, the sprocket actually is going on. Wow, okay. There's a lot of burrs on this axle, as you can see. The sprocket's going to go on there. It's just fitting tight a little bit. It goes on about a ½ inch or more. And it's going to get tight. So that's good news. That's good news. I think when I clean that up, that's going to go on there. And I don't mind if it fits tight. Look at that. That's going to go on there. Alright, like I said, there's a big victory. Now, while we're here, I want to show you how I set the center line of this up. It took me a long time to think that through. You need a reference point to set up the center line of how you're going to set up your, how are you going to set this up? That's important. You need to know one way to set this up. Okay, I needed a reference to set this up. Let me see if the camera... Excuse me, I get the camera right here. Okay, you need to have a reference to set this up. So I'm quickly going to show you how I set the center line of this up. Now there's some things I know for sure. When you get your dividing wheel, it's going to come with information that this dividing wheel is 3.93 inches to the center. 3.93, that's important, so you know that. Okay, this is a, you notice that's a vice spacer. That's a vice spacer kit. It's perfectly precision ground 6-inch piece. This is 6 inches. So I took my tool head stock and ran it down on top of this 6-inch index. So I knew that I was at 6 inches. To make this short, you can watch this video twice if you care to understand this. I ran this tool cutting wheel and you'll understand this just as soon as I tell you. I ran that cutting wheel down until it barely touched it. You don't touch it hard. It's easy to gently touch this 6-inch altitude. On the cutting tip is 8 millimeters wide. This is an 8 millimeter carbide tip. So I'm at 6 inches, and that's a starting point. Subtract half of the 8 millimeter is 0.155. Right away, find the center of your tooling. Don't do it later. It's way too confusing. Right away, find the center of the tooling is what you want to find, not the bottom. As soon as I subtracted that, I lowered it down 0.155. That means the center of my tooling is at 6 inches. Now the center of my tool is 6 inches. Now you can do something. Now I know that I'm 3.93 inches to the center line of my axle. So I subtracted the 3.93 from 6 inches, and I got the figure to lower the head, the tool, 2.075, 2 inches and 75 thousandths, 2.075. I lowered it to, on the digital readout, of course, all this on the digital readout, that's precision. 2 inches and 75 thousandths down and lock the mill in place, and there you are. You're at the exact center line of that. So that's the way I did it. That's probably not how a professional machinist does it, but that's how I did it. And that leaves one other situation. Important situation. Nobody probably knows how deep to cut this spline. How deep to cut the spline? All right, well, think it through. Take about 2 weeks and think this over. Maybe you've been thinking about it since you saw another video I'm going to put online. Just to help people out, that's all. I'm not... Let's see. You'll understand this. There's no way to measure that. There's no book. There's no standard size for anything when it comes to splines. I'm duplicating it. Here's a Volkswagen axle. I have to duplicate this. Okay, here you go. There, that goes on there. I have to duplicate that. The other Chevrolets I did for a Chevrolet car, they're bigger, they're different. They're 27. They're all going to be different. So I want to duplicate it. So after I did my work on the lathe and prepared this axle to be the same profile as this. This has a nice profile after whatever it was. 0.960 inches. 0.960 inches. So I made this 0.960 inches to duplicate the diameter of this. Okay, here's the trick. Here's what you do. Here's a measuring wire kit. You probably already have a measuring wire kit. You'll be wanting some right away as soon as you start doing any machine work. This is 5.5, 55 thousandths. Stay with me here. You put this wire, you measure the diameter of this. You put the wire, it's important it's small enough to fit in the thread, in the groove. It can't be larger to be outside of the V, outside of the 90-degree spline. You know what I mean. Okay? This is simple. You put that in there and you measure that. And you play around with it and you measure everything until you get the largest measurement. It's 0.994 inches. Okay? 994 inches. You still don't know. You still don't know how deep to cut this. You are guessing at it. You cannot cut it as big as this. This is 55. It would be a mistake to cut it 55. You know that that's too much. It's probably 2/3 of your wire. I cut this once and it was too small. Then you cut a spline. You cut a spline and you put this in here. So you cut one spline. You set it up and you cut one spline. Say you cut it 30 thousandths. Probably won't be right, but you cut it 30